is Unit 1, Section 1.5, Experimental Design, Day 3. So this is our third day working on experimental design, so we're going to wrap some things up here as far as what the components are, maybe a couple different methods that we can look at, and also interpreting the results here. So a couple parts that we could include into our experimental design are whether we keep the design single blind or double blind. So single blind is an experiment where either of the subjects or those that record the data from them don't know which treatment the subjects have been assigned. So that might be where I'm administering an experiment and I know what I'm giving you, but you wouldn't know what you're receiving. That would be single blind. Double blind would be an experiment where both the subjects and those who record the data from them don't know to which treatment the subjects have been assigned. That would be like on Grey's Anatomy, where, Dr. Weber's wife was put into this clinical trial and nobody was supposed to know who got what treatment. That's the idea. Not only do the patients or the subjects in the experiment not know, but neither do the people administering it. They're going to do the same thing no matter what. So in our first example, it says ultrasounds and birth weights. It says, in an experiment, researchers examined the effects of ultrasound on birth weight of babies. Pregnant women participating in the study were randomly assigned to one of the two groups. The first group received an ultrasound and the second group did not. When the subjects' babies were born, their birth weights were recorded. The women who received the ultrasounds had heavier babies. Did the experiment take into account the placebo effect? So remember, the placebo effect was something that we talked about as far as you have to take something to mimic the overall treatment. So the placebo effect is not getting the treatment or getting the treatment and believing that you have effects from it. So in this case, no. The women who did not get an ultrasound may have acted in a way that could affect the birth weights. We don't know that, but we know that they didn't consider it. So the women who did not get an ultrasound may have influenced the birth weight. And again, this is kind of a stretch where it's like, what control do you have? But we don't know what's going on as far as whether or not they have affected or have not affected that birth weight idea. So is this experiment double blind or single blind? This is neither right now, because everyone involved knows what the treatments are. So that means the woman getting the ultrasound knows she's getting an ultrasound. The woman that didn't get it knows she didn't get it. They can identify each other by that group. Also, the tech that's recording these ultrasounds in this experiment right now they know who they gave the treatment to. So if we were to improve this design to address the idea of a placebo, we would need to have the technicians pretend to give all women the ultrasound, but only actually scan a randomly selected group. So this would take into account the placebo effect. So now the women wouldn't know what group they're part of. So that would help us at least create a single blind study. And that would also be by don't tell the women what group they're part of. If we wanted to, we could have a double blind study by assigning the groups and then having the technicians record if they did or did not give the ultrasound, as well as the baby's weights later on, and that would be a double blind. The single blind right now, though, would be, single blind would be sufficient for this, because we would have, at least all the women involved wouldn't be able to unknowingly influence the birth weight. Okay, on the next part that we're going to talk about is a couple different ways that we can group our experiment so that we can help it with the overall effectiveness and the reliability in it. And so one of the ways is called blocking, and another is called match pairs design. So when we looked at surveys, okay, we could sample a couple of ways that were good: an SRS, a stratified, and we did cluster. Okay, so when we did surveys, these were 3 good ways to take our sample and create and give those surveys to them so that we could then get the results and do inference for the population. Okay, when we look at block, this is going to be a very similar idea to stratify, but now it's in an experiment, so that's why we call it blocking. This is a group of experimental units that are known before the experiment starts to be similar in some way that is expected to affect the response to the treatments. So that could be like freshman, sophomore, junior, senior. There's a known difference or similarity in those groups that maybe we want to address. It could be males and females. It could be, effectiveness as far as, are you closer to a river if you're a plant or further away? These are things that we want to consider to make sure that when we randomly assign, that we're still getting groups that are very similar to each other overall. So a randomized block design has the random assignments of experimental units to treatments carried out separately within each block. Okay, so let's look at this one. When we look at block design, we want to test, in this example, a new drug to see if it makes people stronger. But men are often stronger than women, so maybe gender would be a lurking variable that we want to consider. Okay, so if we already know this is something known before the experiment starts, what we're going to do here is create 2 separate groups. And these groups are called blocks, men and women. Okay? We're going to perform the experiment on each group separately, but the exact same way. Then we have 2 sets of results that we can put together and compare overall about this new drug. So in the block design, we have all the women here and all the males here. So what this would do is this would be allowing us to split them up and still apply our treatment, have the control, and we can compare these 2 groups to get results. Wow, my spelling is off today. And in this group, we would do the exact same methodology. We would have a treatment applied to some of the males and a control applied to some of the males and compare those 2 groups to give us our results. And this would be allowing us to really see if the new drug is making people stronger without randomly assigning and happening to have all men in one group and all women in another group. This just controls that lurking variable of gender. Okay, so randomized block is similar to what we did with stratify. When we stratified, we said, hey, there's a known difference. I'm going to break those up to make sure they're represented well. This is the same idea. An experiment, instead of randomly, instead of sampling and making sure that, now we're randomly assigning. So we want to make sure each of those groups are represented. On the next type is called a match pairs design. And this is using matching pairs of experimental units to create blocks. You are your best pair. So if you can do the experiment twice, this is where you would want to, I'm going to do it something with the new drug and something with the old drug, because that controls all the other lurking variables of genetics, of, background, of lifestyle, all those things that could be affecting how the new drug or the old drug impacts you. That would be something that you could do twice and then be able to compare that. If we went along in this case where we have men and women in this group, we can pair one man with one woman and treat the pair as one unit so that there are an equal number of men and women in each group. And then we'll get one set of results. So here we did the comparison in two different blocked groups. We created this block and said experiment 1, experiment 2 in the exact same way, and we have results. Matched pairs is going to say, okay, every man is going to be paired up with a woman, and we're going to have each of these groups be compared in between. Now we're comparing, okay, what's the difference between here as the improvement? What was the difference between them as the improvement? And so on. And we'll do it not only for the treatment, but also for the control group. And when we compare those, this is where we get those results that will tell us whether or not the new drug is being effective to make people stronger. So maybe in each one of these groups, we take one group as a whole, but we do male minus the female. And we do male minus the female. So each one of these would represent one difference. Okay? If we had another way to do paired would be like if I'm going to do something with my left hand or my right hand. I'm going to apply a treatment to a glove on the right hand and a glove on my left hand, a boot on my left foot and a boot on my right foot. I'm going to do those things in a similar way. Match pairs just means we match at the beginning and then apply our treatment and control. Block says completely separate those groups, and then we're going to apply separately the treatments and the controls as two different groups. So again, should be similar to what we did here. So if we had surveys here and we're sampling an experiment here, we would have our completely randomized design. Stratifying would be like a block design, and cluster would be like a matched pair. Okay? Clusters can be bigger than 2. Matched pair is typically just 2 experimental units in a group. So let's do an example. See if we can clarify this. So it says, researchers want to test if a new laundry detergent cleans better in warm or cold water. They conduct an experiment using numerous pieces of dirty laundry as an experimental unit. The response variable is the cleanliness rating on a scale of 1, still very dirty, up to 10, which is very clean. So what is the treatment and which variable is this? So the treatment is the water temperature. And so we think the water temperature explains the cleanliness rating at the end. So that's where this is going to be our explanatory variable. On the second part, it says, describe and explain a possible lurking variable. So maybe something could be the color of the clothing. It's easier to clean a black shirt than it is a white shirt. It could be the pre-soil level. Are they all dirty the same way? Maybe we have a couple shirts that are dirtier than another way, or dirtier than another shirt, and that's why it got cleaner versus dirtier, whatever that could be. So these are possible lurking variables that are acting on the cleanliness in the end. Our goal here is, can we suggest a randomized block design that would reduce the effects of these lurking variables? Okay, so we would want to do, maybe carry out an experiment blocking on color. So whites and colors separately. So I grew up always sorting those out. Whites in one pile, colors in the other pile. And when I did laundry, that's just how my mom always did it, so that's how I did it. Then when I got to college, I had somebody that said, I don't ever sort them, I just do everything on cold. And now that's what I do, and I don't really know which one's better or worse. But what that would look is I would have a group for the whites here and the colors here of my clothes. And I would have, okay, I'm going to put this shirt, and I'm going to copy and paste that. Maybe I have a couple shirts here that are the whites. And I'm going to have a couple shirts over here that are also white. And this is going to go into warm water. This is going to go into cold water. And I'm going to compare these two groups. Okay? This is one experiment. I'm going to set these up just so that I can compare them. And because I'm blocking, I'm going to do this entire experiment again with this group. And so I'm going to take two of the colored shirts that I have in here and compare it to two of the colored shirts that I have over here and compare the results this way and see what is the difference that this has on the cleanliness rating on very dirty to very clean. So this could be a randomized block design. We know there's a difference in the cleanliness levels of whites and colors. Let's compare the warm and cold, addressing that difference that we know for the color of the clothing. Okay, on this one, we're going to think of this as a matched pair design that should reduce the effects of the lurking variable. So again, now I'm going to pair each white shirt with a colored shirt. And then assign the temperature. So now, okay, I'm going to have this, well, let's get an arrow here. So now my groupings are going to be something like this, where as I look at them, I would have a pair like this now. And I'm going to say, okay, if I have this as my group, maybe I have a couple of those groups in each one. And I'm going to compare this to an entire other group over here, where now here are my comparison, where I have warm here and I have cold here, but I've paired them in such a way that I can say it wasn't because of the coloring of the shirt, because those were grouped in such a way that they were both represented in the warm and the cold. If I had done a completely randomized design, that's what this would look like in the beginning when we just want to research this, so we throw them in there. Okay, that's not taking into account the color, or even right now we haven't addressed the pre-soil level. If I wanted to go back and do the same example on pre-soil level, I could say, okay, instead of addressing the color of the clothing, I'm going to say this is already really dirty and this is going to be semi-clean. You know, how does it work when it's really dirty? How does it work when we're just semi-clean here? But I would then have the white shirt represent a dirty shirt and the purple shirt represent a semi-clean shirt. So again, I could address this lurking variable another way. And as you get really involved into experimental design, you can have levels and levels and levels that you would break this down. So we could even, and again, we won't get this crazy on the AP test or any descriptions that we were doing, but we could say, okay, we're going to do this 4 times and do whites that are dirty, whites that are semi-clean, colors that are dirty, colors that are semi-clean, and we could do 4 different groups there, blocking not only on the clothing color, but also on the pre-soil level. The differences are blocks. These blocks are very similar to each other. Where the matched pairs, we have these pairings that guarantee that we have always each one represented in the treatments. Okay, so today we talked about single blind, double blind, and then really we want to drive home the difference and the reason we would use block design or a matched pairs design. Let me know if you have any questions on the homework, and I hope you have a good one.